Hello guys, welcome back for another video about Azure EventHub and Databricks. Today we are going to see how to stream data from our local computer using Python to Databricks through EventHub. The goal here is to send data every couple of seconds and save them in a Delta table in the Hive metastore in Databricks. It's a very common scenario to have to stream data straight into Delta tables. Using Spark, we read the incoming data in real time. We transform and filter the data if it's necessary, and then save it in the Hive metastore in Delta format. It's very helpful if you want to gather data from IoT devices or you want to build a Delta warehouse in Databricks. The code is already provided in Azure documentation, so essentially we just need to follow the steps one by one. Having said that, let's jump into the example. This is the Azure documentation about how to send or receive events from event hubs by using Python. So if you scroll down, what you have to do first is to install the Azure EventHub library and scroll down again where it says send events. Now there are two options, the passwordless and the connection string. I will use the connection string to connect to EventHub and send data. Here is the Python code, as you can see. You copy that and you paste it into your VS Code. Now there we have to get those strings here, the EventHub connection string and the EventHub name. And if you scroll up again, you will see where you can find those strings. Okay, so let's create an event hubs now. Click on event hubs, create event hubs namespace. Let's create one. Select your resource group, event hub. Yep. Select your location, West Europe for me. Pricing tier, select the basic one. Throughput units, 1 is fine, we don't need more. Leave everything as is, review and create an event hubs namespace. Click on create. And after that, we have to create an event hub instance. That's the goal here. Get the connection string from the event hub instance, place it into our code, and then we can start sending events. So let's wait for a couple of seconds. Here we are. Let's go to resource. Let's scroll down on the left hand side on the panel. Click on event hubs under entities. Click event hub. Event hub. That's fine. Partition tube. Yep. Next capture, we don't need this option right now, so click review and create an event hub instance. So now scroll up where it says shared access policies, and here we will find the policy here, by the default policy, which is by default it's managed, and what we need is get a connection string primary key. So copy that and paste it into your VS Code. Let me switch. Let me replace the event hub string connection and event hub name. So let me get the event hub name. Let's paste it. Yeah, that's fine. So now this will create an event hub producer client, which we provide the connection string, and then we will be able to create batches of data and send it to event hub. We can send 3 events right now, but let's modify the script. Remove that. Let's say we want to send a JSON, right? So let's call this. Let's create a dictionary with some properties. So a dictionary with some fields. Let's say we have 3 fields. Let's pass 3 fields. One would be device ID, and that would be a random integer. So random.rand int 1 from 1 up to 100, we are going to generate a random integer. Now let's import random here, import random, right? And we will get a random integer for device ID. Then let's add another, and let's call it device number. Device number. Again, the same thing, give it a random integer for from 1 to 100, that's fine. And the last one, that would be, let's see, let's give it some countries, device country, and that would be random dot choice. And let's create a list with countries, so let's call it countries, and then let's create a list, provide a few elements here: Greece, USA, UK, India. And here now, using the randoms.choice option, it's going to pick a random country from this list here, right? So we have this dictionary with those three fields. Now, what do we want to do is to actually send this data into EventHub. Now, if you paste it here, it's just a dictionary. So first we need to use JSON dumps. So let's import JSON, and here use JSON.dumps and pass the dictionary, right? Okay. Now let's add a counter so we can send data every couple of seconds. So let's create a counter that would be, let's say, 5, right? And while, let's add the while loop here, while counter greater than 0, then perform all this stuff. Let's move that here, this as well. And now let's use sleep. So let's wait for 3 seconds, right? And then counter should be counter -1. Let's import time here, import time, save that. Let's print the data every time we send it. So print the dictionary, click on save, and then let's run it again. And in theory, every 3 seconds we should generate and send random data. So the first iteration was, this data here. The second one, this data here. The third one, this here. The fourth one, Greece, and the last one, Greece again. And we have generated random numbers, random device numbers, device IDs, and device countries. So if we switch to Azure EventHub, here on your EventHub, in the overview blade, you will see all the requests. I have already, run the program a few times. That's why you see more messages. And here you can see the spikes, meaning that EventHub has already received messages. Perfect. The next thing we need to do here is create a Databricks. So let's search for Databricks. Databricks. If I spell it right. And here we are. Let's create a new one. The resource group. Select your resource group. Then we have, just provide the name for your workspace. Select your location. And pricing tier should be trial, because we are experimenting now. Leave everything as it is, review and create, and let's create Databricks workspace. Our Databricks workspace has been deployed, so click on go to resource, launch workspace. There are a couple of things that we need to do before we start writing Spark code. the first one is to install the Spark library, right? I will show you how to do that. And the next one and the other one is actually a lot simpler, is to enable in the user interface how to see the Databricks file system to navigate through the user interface. So let's create a cluster, because we need the cluster apparently. Create a cluster. Click on create a cluster. Leave everything as is. You don't need to do anything here. Create cluster. This will take a few minutes, so be patient with that. In the meantime, I will show you that in libraries that you have to install new and click on Maven and provide the coordinates. I'm using this EventHub's Spark version 2.12 and then 2.3.22. So you can use other versions if you want, but I have checked that with this version everything works as expected, so I'm satisfied with this version. Click on install, and let's wait for the cluster to be created, and we have to install the library into the cluster. Okay, so the cluster has been created, the library has been installed. Now sometimes in order for the library to work, you have to restart the cluster. Hopefully this is not the case. Let's click on workspace, and then under users, select your user and create a new notebook. And in this notebook I'm going to paste the code from my notes. It's nothing extraordinary, it is just the code in order to start receiving data from event hubs. I'm just too lazy to type it out right now because it's a big one. Okay, so first we have to import the necessary libraries, sql.types and sql.functions, datetime, you will see why, and JSON. Now the first thing we need to provide is the connection string, right? Let's go back into our Event Hub, click on your Event Hub instance, and then go here under settings where it says shared access policy. Click on add, click on manage, and type a policy name. Click on that, and under your policy, when you click your policy, click on the connection string primary key. Click here and paste it here. Now we have a dictionary that we have to create properties to populate it with values for certain properties like eventhubs.connectionString, which is a connection string that we provided up here, and we encrypt it because the latest versions require that to encrypt the connection string, and then we have to define the consumer group. So in your dictionary, in a property called eventhubs.consumerGroup, just put your consumer group. Now I have only a default consumer group here. You can create a new one if you want. I just leave it as it is, right, the default one. That's fine. And then we have to define the JSON schema. So the incoming data, remember we generated a JSON with 3 columns and 3 fields: device ID, device number, device country. And here we have to provide the schema for this JSON. Device ID is obviously of type integer and it's nullable. The same for device number, and for device country, this is of type string, that's why it's string type here, and this is nullable as well. Now this is the key line. We have to use spark.readstream.format event hubs here. .options, we unpack the dictionary with all those properties filled in, and then .load, and this data frame will receive the streaming data in real time. Now this data frame here, Spark adds extra columns, but the columns that we want, the column that contains the data that we sent is in the body column. So here we select the body column and we cast it as string, and then from JSON we pass the JSON schema, and this will give us a data frame as we want it, only with the data that we want. Now, how can we get the data from this body column that we casted here as string? Now, we can do that by using df.select, and because it's nested now, there are nested columns. We have to select body.device ID, body.device number, and body.device date. Then we can perform filtering, transformations, calculations, whatever we want with this data that we receive. And the last step is to write the data into Delta table. Here we have to type dataframe.writeStream. Output mode is append. Yeah, there are several output modes, but here we use append. Dot option checkpoint location, and here is the location that we are going to save our checkpoint data, meaning so if something happens and the pipeline breaks, right, when we resume the Spark streaming, based on the checkpoints, which saves the state of the data, it's going to pick it up from where it was left, right? This is perfect. We don't have to maintain this state ourselves. By default, Delta here, Spark provides a checkpoint location. We can provide a custom checkpoint location like we did now here, and then save the state of the data. Format is Delta apparently, and we can partition by the device country here. I just use partition by to show you that when you create a table, you can use partition by even if you are streaming data. And .table, the delta, just provide a name for your delta table. Await termination means that Spark is waiting for something to interrupt it in order to finish. So if you click Control F, it's going to terminate. Let's run this and see what happens. We can see where it says, like Spark jobs, so it's loading. Now, let me send some data from Python. Let me run this. And now, in theory, we should be receiving data from EventHub, the data that we sent from our local machine, and it should be stored in this Delta data table. How can you find this table? So click on data, and under Hive Metastore you have default, and click on, in theory you should have a table there, the table that we created, and if you click on sample data you will see that we started sending data and we started receiving data in Databricks, and we are storing the data here. Let's go back to our notebook. So you cannot see anything because I haven't displayed any data frame, so you don't see the data here being displayed, but you can go here into the Hive Metastore and check the sample data. But if you want to query this table, what you can do here is add a cell, and let's use SQL and select everything from Delta data. So if we run this, well, first we need to stop to interrupt the streaming pipeline. So click on interrupt and run this one. And here we should get the data that we received, right? It's very, very simple. As you can see, we have a table now, and using SQL, we can query the table, do whatever we want, and build our data pipeline. Splendid, everything is working as expected. However, there is one small issue. we cannot have the cluster on 24/7 because it's very expensive. So we can turn it off and then turn it back on and read all the accumulated messages in the queue and then shut it down again. How can we do that? Using a trigger. So here, as you can see, I added a trigger. You have to click .trigger once true. So this is going to run the job. It's going to pick up the accumulated messages that is in the queue and then shut down again. So it's going to terminate the job. This is what we want. Okay, so let me send a few more data that will be stored in the queue, and then we are going to enable the Spark streaming job. It's going to run one time and it's going to pick up the new data. So let's run it again. And now, as you can see, it's going to run the command and it's going to finish. So it took 3.66 seconds, right? And now if we run again, we will see a lot more data in our table. So it ran one time, it picked up all the accumulated data in the queue, and then it shut down again. It terminated the job, which is what we want, because we don't want the cluster to be on 24/7 unless the company is paying. But yeah, don't do that. Another thing I would like to show you very quickly is to define a starting position and an ending position. So how can you do that? You provide these dictionaries here. Starting event position, the offset would be -1, so it will start from the beginning. And here we have the ending event position, the offset is none, but we have the enqueued time, which is today's time in this format, which is necessary. And then we pass these JSON dumps, we convert the dictionary into JSON dumps into strings, and here we pass it to the EventHubs.starting position and .ending position. And this right now, let's move this up here. And now here we have this starting position and the ending position, and you can define the offset yourself if this is what you want, and maybe it's necessary in some cases. As you can see, we broke down this job into stages, so we can be able to filter the data, transform the data, and do cleanse the data before we save the data into our delta table. But we can follow a different approach. Add one cell and let me paste the code. Actually, this should be in a different cell. So here we are streaming the data from Event Hubs, and then we write the streaming data right into a delta table without transforming anything. Again, we provide the telemetry, the checkpoint option, the checkpoint location, append output mode, trigger once, etc., and then we save the data into delta data 2, right? So from this table, and from this table, then using Spark SQL, we select the body column, we perform the transformation, the casting here, and then we select the columns we want. So let me send some data, and then let me run this script. Actually, let me remove trigger once and let me run it like that. So we should be able to see the data as it coming. Spark jobs, as you can see, the data is coming, right? That's fine. Now, let me stop that. Let me cancel this. And let me select the data from the table. And here we have you can see the data that we stored in this delta data2 table, right? This is another way, just instead of break it down into into smaller jobs here to perform the transformations before we save the data. Instead, we can write the data straight into a delta table and then perform whatever transformations we want. This is it for today, guys. I hope you enjoyed the video. I'm going to upload the code on GitHub, although you can find it on Azure documentation. It's not very complicated. We didn't make any complicated changes, any difficult changes. If you like the video, please click the like button, leave a comment and subscribe to the channel, and I will see you in the next one. Thank you.